On July 1st, NASA's deep space monitors detected something unusual, a faint, fast-moving object altering its course as it entered the inner solar system. Its behavior defied every model of known comets, and early simulations placed its trajectory uncomfortably close to Earth. When the first high-resolution image of 3I Atlas was released, it confirmed scientists' fears this was no ordinary comet. Unlike ʻOumuamua or Borisov, Atlas arrived with a nucleus several kilometers wide and a mass estimated at more than 30 billion tons, a relic older than our solar system. Launched from the far reaches of the galactic disk, no planet, not even a rogue world, could have thrown such a body our way. Only the violence of another sun or the chaos of a dying star could explain its journey. As the news spread, telescopes around the world, Hubble, James Webb, and observatories from Hawaii to the Canary Islands turned to follow the visitor. Night after night, Atlas grew brighter, its shape twisting and stretching, suggesting fragmentation. The challenge was no longer tracking a single body, but mapping a cloud of fragments, each following its own unpredictable path through space. What began as a solid object had become a blur, an expanding swarm of debris. Imaging teams worked around the clock, measuring its growing coma and shifting tail, but the results only deepened the mystery. Some fragments shone brightly, others were dark and invisible, tumbling unseen through the void. The largest pieces, possibly a kilometer across, disappeared into the solar glare, untrackable and dangerous. Supercomputers in Pasadena and Paris simulated millions of potential trajectories. Some fragments would miss Earth entirely. Others, driven by solar winds or outgassing, could drift into blind spots in our detection network. The danger wasn't what we could see, it was what we couldn't. A single hidden fragment could linger for months before emerging, its path changed by subtle forces no one could predict. Impact modeling teams ran scenario after scenario. A 200-meter fragment striking Earth at cosmic velocity would release over 1,000 megatons of energy, more than every nuclear weapon ever detonated. A 1-kilometer impactor would unleash 100,000 megatons, enough to collapse civilization itself. The blast would ignite cities, trigger tsunamis, and plunge the planet into years of global winter. Humanity would survive, but barely. As if that weren't enough, a new concern arose. 3I Atlas's dust, trillions of tons of ionized material, was on a course that would take it dangerously close to the sun on October 29th. Solar physicists debated whether this could trigger instability in the sun's corona. Most dismissed the idea as impossible. No comet could inject enough material to influence a star. Yet a few researchers, modeling exotic magnetic interactions, warned of a rare chain reaction, a hyper-charged coronal mass ejection capable of crippling Earth's power grids. Even a fraction of such an event would be devastating. The blackout of Quebec in 1989 lasted only 9 hours, but it revealed how fragile our systems are. Today, with satellites, GPS, and interconnected grids spanning the globe, a superstorm could plunge entire continents into darkness for months. Transformers weighing hundreds of tons would burn out, satellites would fail, and communications would collapse. Civilization's lifeblood, electricity, would vanish in an instant. And still another layer of danger loomed. As Atlas fragmented, it released a cloud of dust, spreading through the inner solar system. Ancient matter from another star, tens of billions of tons of it. By 2026, Earth's orbit will pass close to this cloud. Most scientists predict no direct impact, but astrobiologists can't ignore the possibility that interstellar dust might carry something more than minerals, perhaps microscopic life, or something stranger, the idea of panspermia, life traveling between stars. has gained credibility in recent years. Some theorists even suggest that such debris could carry engineered particles, biological or mechanical, designed to seed other worlds. Biosafety agencies from the CDC to Porton Down now quietly rehearse containment protocols for unknown agents. Particles without DNA, chemistry, or precedent. Detection may prove harder than containment. If alien biology exists, it might not even register as alive by our standards. Meanwhile, SETI analysts have noticed a troubling pattern. In just 8 years, 3 confirmed interstellar objects, ʻOumuamua in 2017, Borisov in 2019, and now 3I Atlas in 2025, have entered our solar system. Before that, there were none. Random coincidence or something more deliberate? Some whisper that these objects might be markers, breadcrumbs left by a civilization capable of shaping celestial orbits. Most scientists reject that idea, but the timing remains impossible to ignore. As 3I Atlas vanishes behind the sun, the truth remains out of reach. No peer-reviewed studies confirm that Earth will pass through its debris stream in 2026, nor that its dust could trigger a solar catastrophe. But the object has already forced a reckoning. It has revealed how fragile our monitoring systems are, how unprepared we remain for threats from beyond the stars, and how little we truly understand about what moves through the dark between suns. For now, 3I's Atlas is gone, but its legacy endures a reminder that the next visitor might not just be a comet, but a test of whether our civilization is ready to face the universe itself.